Welcome! This video demonstrates the training of an artificial agent. The problem is one of many example problems in the book Reinforcement Learning Explained. As the video indicates, the problem is about driving a car, specifically how to avoid colliding with a bull. In the blocked road problem, there are three possible actions: move north, move east, or move south. Here, moving east means staying in the same lane. The state is defined by two variables, x and y, a two-dimensional position. The x position ranges from 0 to 3, where 3 is a terminal state. The y position can take one of two values, 0 or 1. The starting position is always at x equals 0. The bull is located at x equals 3 and y equals 1. If the agent crashes into the bull, it receives a severe negative reward of -100. Changing lanes, that is, changing the y position, results in a small negative reward of -1.
The method to solve the problem is Q-learning. It is an algorithm invented in the 1980s. The idea is to select an action A and use the resulting reward to update the function called Q. Once the function is established, it can be evaluated for different actions in a given state. The action that gives the maximum Q value is considered the best one. The Q update is recursive, meaning that the function partly depends on itself. In the variant used here, the Q function is tabular, which means that the states are discrete.
The frame on the left represents the environment. The red object denotes the bull. This frame also displays information such as the number of elapsed episodes. The frame on the right shows the agent's memory. The three upper plots represent the Q function. For example, the upper right cell shows the value of taking the north action in the state where x equals 2 and y equals 1. Black indicates a severe negative reward, while white represents 0 reward. The value function is also shown. It represents the value of the best action in each state. At the bottom, the policy is illustrated. The arrows indicate the best action to take in each specific state. The policy shown here is still suboptimal. For example, it sometimes suggests moving north, even though any human would recognize that this is a bad idea. The agent training now begins. The animation speed is slow to enable smooth interpretation. Let us pause for a moment and reflect. After just a few episodes, some essential learning has already taken place. The agent has learned that taking the east or north action when positioned next to the bull in the upper lane is a bad idea. It leads to a collision. This is indicated by the black cells, which represent strongly negative state action values. And now let us observe a few more episodes. We begin to see more promising behavior. The agent has learned to avoid the bull. The Q function returns severe negative values for actions resulting in a collision. Now we speed up the animation to fast-forward evolution. As you can see, the agent memory is further updated. Wonderful. This is fantastic. We now have a trained agent in place. We can observe the desired behavior. The bull is consistently avoided. We can also see that the value function has converged. The value of being in the south lane is 0 because no lane change is required. The value of being in the upper lane is slightly negative since a lane change is necessary. The problem presented here is one of many example problems described in the book Reinforcement Learning Explained. This was only a brief description. Many more details are presented in the book. Please visit the book's homepage for more information.